Hello everyone, my name is Vince Hammond. I'm your host for this series of videos on customizing DraftSight. This is our session 5, or technically if you're just here to go through the Lisp programming, this is the third session in that series. So to get started, I wanted to go through just a quick review of what we covered in the last video series. And then we'll go through those lab examples. At the very end of that series, I gave you a couple labs to try to see if you could do on your own. And then I'll go through examples of how I would accomplish those tasks. We'll dive into selection sets, entity selection. We'll look at entity data and tables. And then we'll get into also conditional functions and how to do different conditional situations within Lisp, and then repeating loops. And then we'll get a little deeper into some of the data tables. So just to get started, in the last session, we covered list operations, string functions, converting values, drawing variables, and I gave you those two examples. So let's take a look at the first one. So in the first example, what we wanted to do is just grab the username, grab the current drawing file name and path, and then take that information, put it together, and put it up in an alert. And so how we start that is let's start by setting a variable. In this case, I'm going to use a variable called name. I'm going to use a function called getVar, and there is a variable in the drawing called loginName, and this will get the current username. And then I'm going to set another variable to the getVar variable called drawingName. There's another one that I'm going to set, which is dwgp for drawing prefix. This is the path of where that drawing is. And then I'm going to grab the date. Now, if you've looked at this, I don't know if you've check this out, but when we grab the date is a numerical value. It's not a string. And so in order to strip away the characters for the date, we have to convert it over to a string. And the function, if you recall, last time we covered this, it's real to string artos. And we are going to use a decimal and 0 places for the decimal. And then what we do is we're going to take that string, we're going to take the first 4 characters, which will represent the year. Then we'll start at the 5th character, take the next 2, that'll represent the month. Start the 7th character, take the next 2 characters, and that'll be the day. And then we're going to put all this information together with a function called stringcat. And we're going to take created by, we're going to use the variable called name that we picked up here, the drawing path, the drawing name, a space, we'll put the month, a dash, the day, and the year in that. And then at the very end, we'll close this set queue. If you recall, we could do set queue on each of these lines, but in this case, I'm going to use one set queue function to set all these variables, and then we'll close that set queue, and then at the very end, we'll do an alert, and it should pop up a alert box on the screen that says created by my login name, Vince, and so on. So the reason I like this example is because oftentimes in the future, as you start writing routines, you may either want to grab the current username and date or the drawing that you're doing something to and then record that somewhere or document it. Or if you want to put that information into title block, this is just a really good example that you guys may be able to use to assemble or pull that data. And the second example that I gave you was basically taking that date, that C date that we picked up that was a numerical value, and converting it into a format that is your preference. Maybe it's month, day, year. Sometimes we use year, month, day, depending on, in certain countries we have different formats. Now, myself personally, as I record things, for instance, if I create backup files or I record files, or like history of things that I've done, I really like to use year, month, day, so that numerically, as those things fall into a folder, they're in a sequential order that's easier for me to follow, especially if I span over multiple years. It's really easy to sort through that data if I'm starting with the year and then going to the month and the day. Now, if you recall, and last time we talked about this, there is a variable, setVar variable called cdate, and there's also in DraftSight there's one called getDT. Now they both do the same thing. However, when we look at getDT, that variable only exists in DraftSight. You do not have that variable in other CAD systems. Whereas cdate actually comes from some of the other CAD systems, and it will work in DraftSight. So keep that in mind. This is another one of those small tips if you're writing an application that has to run in multiple platforms, multiple applications, you might want to use cdate instead of the getDT getVar variable. So what does that code look like? Well, first, we're just going to create a function. We're not going to create a command, but we're just going to create a function that grabs the current date and puts it in this format. And so I define a function. We'll call it getDate. And then you'll notice here that I'm going to declare a bunch of local variables. Now, I don't believe I showed you an example of this in the last session, but when I declare a local variable, that means that that variable, D, D1, D2, D3, so on, is only available in this function, and as soon as this function closes, those variables are gone. That's basically a local variable. So this is really how we declare those. We don't have to declare the type or how big or how small. We just declare that they exist. So let's start with the first one. I'm going to again use the setQ function, and we'll set D to get this current date, and then we're going to convert it from a real number to a string, and we're going to do a decimal format 6 places. Actually, why don't we just bounce over to DraftSight? I do want to show you that. So if we type in here get var cdate, I want to show you the format that it displays it. You'll notice down here it's or if I just hit F2 here, you'll see a little better. The date, again, it's a real number. It's the current date, time in hours, minutes, seconds, and milliseconds. Now, again, this is a real number, so when we convert it over, we want to convert it to however much information we want. So for instance, if I want hours and minutes, I could say take 4 place decimals. If I want the seconds, I might go 6 place decimals, or if I actually want milliseconds, I could go further than that. But that's just to show you that in this case, I'm going to strip away and just take hours, minutes, and seconds, 6 places to set it to my variable here, which is D. Now, once it's a string, we can strip away. We can say, okay, I want to start at the 5th character and take 2 characters. That's the month. 7th character, 2 characters. That's the day. If I start at the 1st character and take 4, that's, of course, the year. But now, in some cases, we use a 2-place decimal or 2-place string for year. If you want to just say 21 instead of 2021, you would start at the 3rd character and take 2. Otherwise, we'll get the full 4-digit year. All right, so when we take the 10th character and we take the next 2, that's the hour. The 12th character, the next 2 is minutes, and then, of course, seconds. So we can create 2. Now, I just, instead of putting this down on the second line, I just put it all on the same line here. I've got 2 variables that I'm creating. One is date, where I'm going to string cat D1 with a slash D2, D3 to give me my date, or time is going to be D4 with a colon, D5, and D6, and those things are just put together. So in this example, this function will set the 2 variables, date and time, that are then available for other programs. Now notice I didn't declare date or time as a local variable because I want those to sort of be global and just still exist after this function runs. So D through D6, those variables will go away. They wouldn't exist anymore after this function runs, but date and time would still be there. So just a good example that you might use to set up these variables. All right, so in the last session, we talked about selection sets, and what I showed was an example of how we use the ssget function, which grabs everything in the drawing, but then filters through these lists or these association lists. Notice the 0 association list for circle would just give us all circles, or if we wanted to say all circles on the layer text, we use 8 as the association list for the text to supply that. Now, this is specifically for grabbing selection sets. What if we want to grab a specific entity? And so the next thing we're going to cover is how to grab a specific object within the drawing. To do that, we use a function called entSelect or entSel. It's basically an abbreviation for entity selection, entSel. And what it'll return is a list, of course, with the first item in the list being the entity name, and the second list within this list is, notice it's 3 numbers, it's X, Y, and Z, the location where you selected that object or that item. And so that's really, keep that in mind, it's the place you physically picked to grab that item, and that shows up as that second item in the list. So let's say we wanted to create a function that grabs the object. Now with entCell, we can add a string or a prompt to the command as a second item here, so it will prompt on the line to, in this case, pick object. And so if we want to set a variable to the variable named ent01 to an object, we can simply say open parentheses setQ ent1 to this function called entCell pick the object. Now, if you notice, when I set this, it will set both this whole list. Now, oftentimes I just want to grab the entity name, not both of these pieces of information. And so I may want to strip out. In order to do that, the function we use, remember, to pick the first item in the list is called car. So this is most likely how you're going to use this function. You're going to say, I want to pick this object using entCell. I want to grab the entity name from there, and I want to set that entity name to 01. Now, let's say you actually want that point, that second item in the list. How would you do that? So the way I would accomplish that is, first I would just set this object, this list, to a variable. In this case, let's use n. And then what I can do is say, let's take the first item in the list, which is n, and set that to the entity name. And then we'll take the second item in the list. In this case, I'm going to use the command called, or the function called nth to grab. Remember, one is, the list starts with 0 and 1 is the second position. So we're going to nth 1 n to grab this list within the list. Now we could also do it this way. We could also grab the CDR, meaning everything but the first item in the list, but then we still have to grab the first item in the list. And again, I think I explained this last time. Sometimes it gets confusing because it's a list within a list, and we have to grab that twice. And so my preference, I think, is to use nth in this situation. They both will give you the same result, but I think this one, from my perspective, is probably just a little less code. All right, so there are a couple different functions that we can use to grab entities. Now, the one I just showed you was entSelect, where we physically pick on an entity. The other is entLast. This will be used for grabbing the last object created within the drawing. Oftentimes I use entLast after I create something. Let's say I make a copy, or I draw a piece of, draw entities, circle, lines, whatever. Once I've placed it, sometimes I'll grab that last entity, so then I can grab its entity name and assign it to a variable. So entLast is very useful. We use this a lot of times after things have been created, or to grab the last item that's in the list. Now there's also another function called entNext. And so if we just call entNext without any options here, just as on its own, technically, while it says entNext, without any variables, it actually grabs the first item that was created in the drawing. So once we've done that, if we take an entity name and we say entNext and then the name of that entity, it selects the next entity after that item. So entNext is useful. Sometimes we use it to grab, and maybe we'll select, and we want to run through every single object one at a time in a drawing. We can use entNext to do that, using the previous selected object or entity. So there's those two. And then once we've selected this entity, or we have this entity name, let's say we want to get the data from that object or that entity. We use a function called entGet to grab the data from that object. And so here's an example where I would use entity selection, and I would take the first item in the list, which is that entity name, and then I'm going to entGet, or get the data from that object. And so maybe a good way to do this, it looks a little bit better. This is the function that I use, but let's say I want to set it to a variable. We're going to set the variable entData1. We'll use that as a variable name, but we'll run entSelect with a prompt, and then we'll grab the first item. We'll then get the data, and we'll set it to this variable name. What does that look like in DraftSight? So if I come over here, and I'll just do this. If we say set Q, I'll just use n to ent get car and select. and I'll just say pick. But you know what? I have no objects in this drawing, so let's just do this. I'll just say pick. We'll do this 1, 2, 3, 4. And now it's saying pick, but notice I have nothing in here. 0 found. So I'm getting that error. It's invalid. But if we just draw a line, and I draw it from here to here, and I just repeat that same sequence, and I pick on it, there you go. It's going to show me the data. So again, here's that data list. Let's kind of talk about what that looks like in detail. And that's really what we call entity tables or entity data tables. So when I pick that, you'll notice it gave me this long list of all these things. Now at first it looks sort of complicated, but once you get to understand what's in here, it's really the DXF data, or it's the data for this object, and it's really not hard to understand. You start to see what's going on here after you've seen this quite a bit. So for instance, it's a list with a bunch of association lists within it, as we talked about this in the past. So this is a good example of association list. So here, if I look for 0, it tells me that that object I selected is a line. If I look at number 5, this is an entity handle. It's a random handle that exists. We'll talk about that later on in some of the advanced sequences and things that we look at, but this is sometimes a good piece of information to retrieve from the object. Now in this case, if you notice, there's no association list for 6, which is line type. So if that doesn't exist, then the default for this line would be to take and associate the line type by layer. So notice sometimes when we have things missing like line type or color or things like that, then the default is to take on the parameters or the settings that are in the layer for that object. So if we go on, you'll notice 8, and we've covered this before, the 8 association list for layer is 8. So you'll notice this line is sitting on layer 0. And then there's 2 more. There's 10 and 11. If you notice, 10 and 11 are both 3-digit numbers. So 10 is often a start point or an insertion point. For instance, if it's a block or other things, you'll see that 10 is that start point. And then in this case, because it's a line, it has a secondary point, which is the end point, which in this case is 3 numbers, 38, 17, 0. So those are the start point and end point of the line. For the most part, these are probably the most useful pieces of information you're going to grab from these objects. Here's another example. In this case, we're looking at a line. And if you'll notice, number 8 is wall, so it's a line on layer wall. And in this case, number 62 is the color. So in this case, it's a line on layer wall that is color 4, color cyan. And then let's look at one more example. Here's a circle. If we look at this, the entity type 0 is circle. It's on layer dims. There's no color, so you don't see a 62 in here, so the color is going to be by layer. There is a center point, and that's 10. And there's my 3, X, Y, and Z for my center point. And then 40 in this case is the radius. Now these, when you look at these numbers, they all follow what's called the DXF standard. So there are different charts and things you can look up to find out, based on its entity type, what the association lists are for that type. There's an entire list of things. But for the most part, what I like to do is I'll simply list these objects out, look at the data, and from there I can kind of figure out what the information is from this drawing. Now let's say I wanted to grab the layer from the circle and set that as a variable. So here we go. Again, with Lisp, we're going to start from the inside out. We're going to do an entity selection. We're going to take the entity name. We're going to grab that data. We're going to look at the association list, which is 8. And then we're going to take everything but the first item in the list, so that should give us dims, and set it to the variable called entLayer. And so there's an example of, by picking on an object, wanting to grab the layer for that object, that's the sequence that you would use to do that. So the next thing I want to cover is conditional statements. When we can compare things numerically or strings, there's a whole different level of a whole different list of functions that we can use to do this. So the first one is equals. It's an equal symbol. If I say, does A equal B, if these are 2 variables, if that is true, it returns a T. If it's not, it returns a nil. We can also say not equal by using a / equal. So if A does not equal B, it'll return nil. Or if it's true that these 2 are not equal, then it would return T. Basically the exact opposite here. We can use characters like less than and greater than. If A is greater than B, Or we can also say if it's less than and equal to or greater than and equal to by putting those two together with the equal sign coming after the less than or greater than symbol. Now, traditionally what I've found is in other CAD systems, we usually use the equal sign specifically for numeric values. You don't use them for strings. But what I found in my tests in DraftSight is that I can actually use the equal symbol on strings within DraftSight, which is a little unique, but something to keep in mind. Now, again, this goes back to one of those tips where if I'm writing this application or a program that I'm going to use in multiple CAD systems, I might want to stay with the equal symbol for numeric values, but then use the actual word equal for string values. Now, equal, if you spell it out as the word, it will do either or. It can evaluate A as a numerical value or as a string value and compare it. It just really looks at those to make sure are they equal or not, and then returns a T if they are. Now, if we want to compare strings and say are these two strings not equal, then we use a function called not. So you'll notice, not equals actually two separate functions instead of a single function when we do this within numerical values. Now there's also another function called or, so I could say, check these two. Give me a T if A is equal to B or if B is equal to C, and it'll return a true. So I can compare these. I can basically do two different types of comparisons, and either one will give me a T for true within that function. Or I can also use an and, which means in order to get a T, both A has to equal B and B has to equal C. So these are two different types of conditions that we can create within a routine to validate whether or not things are equal or not equal. Now again, I would recommend if you're doing things with string values, I would use the equals command or function, not just the equal symbol, because there may be problems running this routine in other CAD systems if you were to try to do that. So the next one in terms of a condition that I use a lot is the if statement. And the way that if works is open parenthesis, if is the function. If whatever this next thing in the sequence is true, if it's a T, if it's true, then here's a list. Do this, or if it's not true, do the second list. Now these lists could be a single command, it could be a whole sequence, it could be an entire program. So if the value here is true, do this. If it's not true, do that. And then here's the end of the if statement. So let's show an example of that. Let's say I have the variable ask set to a command called getString. So we say, start a new line. Is today Monday? Yes or no? So I'm going to use a function called getString. I'm going to pause and let the user enter a value, a string value, and then I'm going to set it to the variable ask. Now, if equal ask to a capital Y, then we'll continue. Now, notice with equal, it can be case sensitive. So in some cases, if I want to make sure whether they type a capital Y or a small case y, what we can do, and this is just an example of something I do, is you force whatever the value of this to uppercase. If you remember this, we covered it last time, string case. We're going to convert the variable ask to an uppercase. And if it's equal to an uppercase Y, then we know that this is true. And what happens? If it is true, we're going to alert yes. But if it's not true, we're going to alert no. So remember, here's my statement. If this is true, or in this case, if I do it this way, if it's true, alert yes. If it's not true, alert no. And then here's the close, that closing parenthesis to that entire function. So that's basically how you do an if statement. So let's give another example of it. Let's say I have this command that we showed last time. We're going to make the layer magenta 6, and we're going to set the color to magenta for the layer 6. So here's that example we used before of creating a layer color 6. So let's start with that and then go and ask the user to pick an object. So we're going to use select to pick an object. We're going to send it to entity 01. And then let's get the data from that. So we're going to car entity 1. We're going to get the entity. We're going to do an int get. We're going to set that to, I'll call it dat01 is the variable. And then let's grab the layer from this data. So here's data 01. We're going to do an association list 8. Grab the second item in that list and set it to the layer name. So now we've got the entity, we've got the data, and we've got a variable for the layer name. So here's an example that might be interesting. So if I say if the layer variable is equal to 3, then do this. So we're going to use a command called change properties, chprop. We're going to grab the item. You know, when we run this command, it's going to say select objects, and then we're done selecting objects, so we hit enter. And then one of the options under the change property command is L for layer. So we're going to type L for layer, and then we're going to put in 6. So if the entity is on layer 3, if this is true, we're going to change it to layer 6. If it's not true, we're going to take that entity and move it to layer 2. So this is an example of maybe a condition where we can grab some information and then check to see what it is and then move that object or change that object to that layer. So why don't we take a look at how that looks. So if I come into, say I've got another drawing here we can look at. Then why don't I show you the code for this just so we have it. Give me a second. Drag this over here. So here I put it into Notepad. If you remember Notepad++, Notepad++ shows basically the same thing, just color-coded, a little easier to read. So here we're going to make the layer, we're going to pick an object, and then we're going to grab this information and then change its properties. So how does that work? So if I want to load the function, I called it iflayer.lisp. So if I come in here and say load, I don't know if you can see what I'm doing here. Let me pick one more time. There we go. Load. And it's called iflayer. Close. Enter. Notice down here, first thing it did is it created my layer 6. That was the first thing. And then it's asking me to pick objects. So if I come in here, and if you recall, if it was on layer 3, it should change it over to layer 6. So there it is. That object changed to layer 6. If I run the command again, and I pick on something that's not on layer 6, there it changes it to layer 2. So the reason I like this example is because a lot of times we use Lisp routines to do conversions, to analyze drawings, look at all the objects, and so sometimes you might get a drawing from somebody else and you want to say, well, everything that's on this layer that is this, I want to move it over to this other layer or change it over to this other layer. And so this is a good sequence or just an example of some code that will help you determine how you can analyze things within a drawing, either by selecting them or in the past, if you saw last time we were doing selection sets, you could use a selection set as well. But I thought that would be a good example to show you in terms of a conditional statement. If this is true, go ahead and do this. If not, do that. Now there's another conditional statement that I use very often. It's called a condition. And the difference here is with a conditional statement, it'll continue to test conditions until it finds a true statement. And so here now, instead of just an A or B choice, if it's this, do that. If it's not, do this. Here we can put in the conditional when we have a lot more choices if we're trying to analyze things a little bit deeper. So for instance, and here you notice, and I underlined this here, the condition is the function, and then this first item is an entire list, which is a list of two things. First is, if this is true, do this in the list. The next list is, if this is true, do this. So what does that look like? So here, we start with a conditional statement, and then I create a list of two lists. And it is, the first item is, if the variable ask is equal to an uppercase Y, then let's do this. Let's alert with the yes. And then I can create another condition that says, okay, well, if it didn't match this, what is the next condition? Well, if it's equal to a lowercase y, alert yes, but let's have a lowercase y. Or if the variable ask is set to the text maybe, then alert maybe with a question mark, or so on. You can kind of get the sense here that I can create a whole list of different conditions. And what happens is, unless it finds a match, it'll continue to travel down through all those conditions in order until it gets to the end. Now, let's say you want to basically at the end have it close out and then say, okay, I didn't find anything. So here, if we just put in a T, because remember, it's just looking for true, and t is the function for true. If it comes out here and says, oh, this condition, I didn't find anything, if I hit t for true, it'll alert and say there's no match. And then we have to close that conditional statement. So here we start it, end it, and we can have, there's no limit to the number of conditions you can place in here. But so that's pretty much how it works, and it goes right through that in order. So the next thing to cover is repeat loops. Oftentimes we want to repeat a sequence, and so to do that we use a function called repeat. And so how that works is open parenthesis, simply the command or function called repeat, an integer number of times we want to repeat this, and then the whatever it is that we want to repeat. So a good example of that might be a counter, or we want to add a total to something. So maybe I have a value, total value of 1, and I want to repeat this 5 times. I want to take whatever that variable is, total, and I want to add 5 to it each time. So what happens when we do something like that? I'll just show you an example of this. For instance, if I go to set q n to 1, and I say repeat of, let's say, 5 times, and let's do add to n. Oh, we want to set q this, so set q n to add n plus 5, like I showed my example. We're going to repeat it 5 times. Close that and close that, hit return. Notice the value is 26. Why? Because I started with a value of 1. What happens if I start with a value of 0? Same function, just repeat it 5 times, and of course it's 25. So we're just running through that loop. Now in this case, I'm just adding some numbers, very simple, but in this example, we can repeat an entire program 5 times, or an entire sequence of events, an entire list of commands. So whatever's in that list, we can do that number of times. Now there's another repeat loop that is called a while, and the way while works is while this list or this value is true, continue to do this. Now you have to be careful with while. As you can imagine, if this item never is not true, it will continue to stay in this list for eternity. It never stops waiting for this to not, it just continues to wait for this to not be true to stop the process. So oftentimes you have to be careful with while loops, but I've used them all the time when I want to do specific sequences of events, or I want to check a variable, I want to see if something's exists, and while it exists, I want to continue to do something to it. So while loops are very, very common, but I would just, word of caution, as you start working with these, you may have to cancel or escape out of a sequence if it's sitting there waiting for this to not be true. So what's an example? Well, let's say I want to continually do something while a person picks an object. So what I can do is I could say, well, let's use entity select to pick an object. And while we're picking that object, we want to copy that object over to over, let's say, 3 units or 3 millimeters or 3 inches, whatever your current setting is. So while this is true, it's going to run the copy command. So what does that look like? I have a good example because I think this is kind of neat to show. If I go to my, and here's what I'm going to do is that entire sequence, while I can do an entity select and pick objects, I'm going to copy that. I'm going to just put it all in one line. I put it on 2 lines before. I'm going to just put this all in one line, and I'm going to copy that. And I'm going to come in here to DraftSight. I'm going to go to my text window, F2. Oops, sorry. Let's try that again. F2, and do a paste, and hit enter. So right now it's asking me to pick objects. So if I go into my drawing and I just pick on an object, every time I pick on it, it's just going to make a copy. As long as I continue to pick, it's going to repeat that loop. Now, if I don't pick an object, you'll notice it says 0 found and then nil. It cancels out. So while I'm in that state of picking objects, it'll run this command. It'll do this until this is no longer true. So again, when I picked into space, I didn't select an object. Ent1 became nil, and therefore it stopped running the while loop. So just a good example. Oftentimes I use while loops to, like I said before, test different variables, and if certain things exist, while they exist, I want to run through a certain sequence of events. Now there's another repeat function that is called Foreach, and what that does is it allows us to take a list of items and then for every item in the list do something. So the syntax is Foreach, and then we're going to give it a variable name, which is going to be what we're going to assign the item to. We're going to supply the list, and then this next sequence is going to say, well, do whatever this is to whatever this item is. So what does that syntax look like? So here, if I say for each n within string list, go ahead and print n. So let's say I have a long list of things and I just want to print them out. This will run through the entire list, and for every one of those items in the list, it will print that. So this is also a good example to use. Now, this is something that I wanted to show you as a good example that might be a useful tool for you. As you noticed before, when we looked at those association lists for the entity, it got to be kind of long. In fact, let me jump over here. I want to show you something else. Earlier when I said int get car and select, and I picked on the line, you notice it was, we got that information. But let's say I pick on something that's got a little bit more data to it. Let's say it's a polyline or a block. You'll notice that now when it puts all that information down on the command line down here, it's kind of long and it's kind of hard to read. So what I'm going to show you is an example of a function that I use. Now I call it, it's a command called ventGet or ventGet, and I'm going to define it as a function. I'm going to have two local variables. So these two variables will only exist for this function. The first thing I'm going to do is I'm just going to print to the command line, select an object to entGet, and then this is the Foreach statement. And let's work our way from the inside out. So we're going to do an int select. We're going to grab the first item. We're going to do an int get, and then for every item in the list, which is XX, we're just going to print XX. Then when we're done, we will print 3 dashes so we know we're done. And then I'm going to use a function here called text screen. I haven't shown you this before, but if I use this function called text screen, it's the same as hitting the F2 key on the keyboard, which I've been using to toggle between the text screen and the graphics screen. But if you want to do that within Lisp, I can do that using this text screen function. And then here I'm going to get a string called, I'm going to just say press enter to return to the graphics screen. Now, I'm setting this variable x, but I really don't even have to. It's just, I'm using this as a pause, because you notice I'm not doing anything with x, and it's just a variable that's local. I just throw it away here after this is done. But I use that as a pause, so then I can switch back to the graphics screen, so I don't have to hit the F2 on the keyboard when I'm done reading this information, all the data that came from that object. And then again at the end of this function, I put in a print C to stop that little nil from showing up, just a little cleanup thing. So how does that work? Well, let me do this. I do want to show you that another best practice is, if this is a function that I want to use all the time, we talked about the startup. I'm going to go back to my startup. If you scroll down, I have an example of loading this program as a command function, but what I call a demand load. So oftentimes we use demand loading when we don't want to really load up all the programs that we have, all the functions we have. We only want to load them when somebody needs it or when somebody wants to use it. So this is a little best practice or a little trick that I use to basically create what's called a demand load. So if we just kind of go through the sequence, as you can see, it's a very simple sequence. We're going to define a function, a command called ventGet, which we're not declaring any variables. What the function does is it loads the Lisp routine ventGet and then runs it. So in a sense, it defines in the startup that ventGet exists, and then once it runs and loads up, then that actually replaces itself. It's sort of, but it's a really simple way to do what's called demand loading. So we're not loading up, and you'll see this a lot of times in my startups. I'll have a whole series of functions that I'll just demand load. I won't load them all up. I'll just load them so that they're always there when I need them. And once I run that vent get, it actually will redefine vent get to be the actual command. So here that once I'm in my drawing and the startup had already run, if I just type vent get and I pick on this polyline, notice now what it does is it switches me over to the text window, and then here it says it shows me all this stuff, but it's in a list, and I can scroll through it, which is probably easier to read than this list example I gave up here. It's just a simple little thing, but now as I scroll through, you'll see I see a number of 10s. Those 10s are all the different vertices within the polyline, and so as you read through this, you'll see it's a lightweight polyline. It's currently on the layer 0, and there's other information that's associated, but I can see here's an entire list of a bunch of vertices within that polygon. But like I said, just an example that as you're doing some programs, you're writing your programs, and you want an example of how to list that stuff out in a more easy to read format. This might be a function that you can use. But I guess the key here is it's an example of a for each. So I basically grabbed a whole list of things and just said, okay, for every one of those things, print this out. So that's an example of a for each statement. So the last thing I want to cover in this session is data tables. Now, as you can imagine, when we went through it, we had selection sets where we could grab a whole bunch of items. We could grab individual items, but what about the items that are in the drawing that are not necessarily selectable in terms of being able to pick on them as entities in the drawing? So examples of that might be layers, styles, line types, viewports. These things are sort of values that are there, but I can't specifically grab them to get the data out of them. So we use something called table search. We look in the data tables of the drawing to retrieve that information of those, what I'll call non-visible objects that exist in the drawing. So a really good example of this is a type of object called a layer, and we want to grab the layer information for the layer called wall. So if I say table search, the type, which is layer, and the value, which is wall, it'll return this. It's again a list, and we have dotted pairs within there. So the first thing is 0 is actually the type, which is layer. 2 is the name, which is wall. And then 70 is the status. And so is it on, off, frozen, thawed, locked? You know, there's different numbers to indicate what the current status of that layer is. And then 62 is the color. So if in this case it's 1, so it's color red. And then 6 is the associated line type to that layer, which in this case here is continuous. So an example of where I would want to grab the information from the drawing. Now, sometimes I use an if statement here saying if layer wall exists, and in order to do that, I say if table search layer wall, then I know that the layer wall is there and I can grab the information from it. Or if it's not there, then I can say, well, if it's not here, I want to create it using these default values, but I may not want to create it if it already exists because I don't want to overwrite the current setting. And so that's a good example of where I might use an if statement and grabbing this layer to determine whether or not it exists in the drawing. Now the function table next will search through the drawing, and based on the type, in this case, if we use layer, it will grab the next layer and supply that information sequentially. It'll just keep going through table next to the next layer. But if we start that command, or the first time we run it, if we put a T in here for true, it will start from the beginning of the table list. So if you wanted to write a sequence that goes through and looks at every single layer and grabs that information, you'd use table next. You'd start with T, and then the next time you would just say table next and supply the information. Now in this case, I'm going to use table next block, and if I start with a T, it'll find the first block in the drawing if it exists, and then every time I run table next block, it'll just keep taking the next block in the list. Now in this case, when I say table next block, you'll see here's the list. It's going to say 0 is the block, 2 is the block name. In this case, it's B1. And then there's some values for 70, which is a condition. And then there's an insertion point. Let's talk about this a little bit more in detail. If I look at this, the association list 2 is that name, like I just said. The association 10 list, notice here is 000. This is the base point of a block. Now, keep in mind that this is the block definition, not an insertion of the block. So sometimes this gets confusing, but when we have a drawing and you physically see the block shown on the drawing, that is not the block definition. It's, in essence, it's really an insertion of that block. So if I were to pick on that entity type, it would come back and tell me it's an insert and not a block. So when we use, in order to see the information about the block, we're going to look into the tables of the drawing and get that information about the block. Now in this case, the association 10 is where the base point is inserted, or where it's located on the block. Now, sometimes you may have seen this. You may have gotten blocks from other folks, and you go to insert the block, and you have a point, but the block is floating above, or it's not exactly a point that's on the drawing. Now, to fix that, oftentimes you open up the block editor, and then you move the block object over to 0, 0, and then that becomes its point. Or you can open up that block, and you can change its base to a specific number, and that would be identified here in this list. So just a little bit of best tips when it comes to blocks and getting data around blocks. And we'll cover more of the blocks in the next session because I'm going to do a little bit deeper dive into blocks and attributes and things that we can do with blocks. But we're going to save that for the next session. Now, what are some of the table search data items we can get? Like I mentioned before, we have blocks, we have dimension styles, layers, line types, and style is for text styles. So these are very common. Oftentimes when I open a drawing, I may by default search for my specific style of text, and if it doesn't exist, go ahead and create it. But if it doesn't, or if it already exists, then don't create it. So oftentimes that's a good example of using a table search to verify that something already exists in the drawing to determine whether or not it's set correctly, or if you want to recreate it or set it up. So that's the list of things that we wanted to go through. We talked about selection sets, entity selection. We did a little bit of a deep dive into entity table data to accept information about those objects. We talked about conditional functions and repeat loops, and then we covered data tables. So in our next session, what I'd like to do is go a little bit deeper into blocks. Blocks are very common. We use them all the time, but there are some really unique things that we can do with blocks. How do we manage those? How do we associate data to them? Using attributes, how do we get that data out of those blocks? And then there's other methods that I want to talk, they may be a little bit more advanced, but there might be cases where you want to associate some extended entity data on those objects or on blocks. And I'm going to talk about how we can use that functionality. And then we'll look at file editing. If I can take information in the drawing and export it externally and put it in a different file, or bringing data into a drawing, how we can do that as well. And then I think the last thing we'll cover in that next session is really taking a look at ASCII data, and you'll get to learn about some of the characters and different things that we might run into, or situations that you might want to be aware of when we start looking at strings and specific items within in that data. All right, well, I hope you enjoyed this session, and if you have any questions, please let us know. In the meantime, I look forward to seeing you in the next session. Take care.